Last one for this section. I know it's probably been a long time for you, so we'll try to whip through this for you quickly, and then if you need a break, always pause and take some time and then come back to it. So we're going to be performing operations on rational expressions, and we know how to add and subtract, multiply and divide fractions. So what we need to remember is that this is really almost the same thing as adding and subtracting, multiplying, dividing fractions. We're using all of the same rules. We're just doing it with variables now, so that makes it a little bit more tricky. But you'll get it. We've done it before. So what do we need to remember when we're adding and subtracting? Fractions, you need a common denominator. So how do we do that with these? Well, our common denominator has to be something that works, right? It has to be a full polynomial in common or the factored parts in common. So remember, you can always make your life easier if you factor before you start. So x squared plus 4x plus 4. Now think back, is that something special? Yes, it's a perfect square. So this is x plus 2 over x plus 2, x plus 3. And then there's nothing to break up here, so x minus 7, x plus 3, 2x. Those reduce. What would our common denominator be for our new answer? Well, this side over here has an x minus 3. Conveniently enough, so does this side. But this side has a 2x and this one does not. So this term on this side needs to be multiplied by a 2x over 2x. That'll give us our common denominator as x plus 3 times 2x. Okay. In our numerator, we'll have 2x times x plus 2, so 2x times x plus 2 minus x minus 7. So we're going to simplify the numerator. We can leave the denominator alone. There's nothing to be done with that. It's going to make our life any easier by multiplying it out. So we're going to have 2x squared from this plus 4x minus x, here's where you're going to make your mistake, plus 7. These can combine. This is all over x plus 3 times 2x equals 2x squared plus 3x plus 7. And then just real quick, x plus 3, 2x. 2 times 7 is 14, so our factors, so is this guy going to factorize into something that's x plus 3? No, so we don't need to bother to factor this out to see if it cancels. Multiplying and dividing. What do we need to remember about multiplying and dividing to make our lives easier? Cross reduce. And again, factor so that you can see if you can cross reduce. So look, I even used the same problem as before. This is x plus 2 squared. X plus 2 times x plus 2 can be written as x plus 2 squared over x plus 3 times 2x times x minus 7 over x plus 2. So it's just a little tiny bit different in the denominator than the last problem. Here I have an x plus 2 to the second and an x plus 2 to the first. So if I have a squared and an a here, I'm going to cancel this to become a 1, because one of those is going to reduce out with this guy. So this guy completely goes away, becomes a 1 when I reduce. So then my final answer is just going to be the product of x plus 2 times x minus 7 over x plus 3 times 2x. And there's nothing that can reduce here, so that's just fine with me. If it asks you to completely multiply out the numerator, you could do that, but this is fine for right now. Division, don't forget reciprocals, right? If I have a term divided by a term, I need to take and multiply by the reciprocal of the second term. And I'm going to go to the next page so we have some space to work this out. I'm going to factor. So x minus 2 squared is the difference of perfect squared. So x minus 2 times x plus 2. And then x squared minus 3 is also the difference of perfect squares, but it would be root 3 here. So I don't know that that necessarily helps us. So x squared minus 3, and then it doesn't factor into something that's helpful for us, so I'm just going to put it times 1 there. Oh, this is supposed to be division still here, because I just rewrote it exactly like it was on the front page. And now we're going to multiply by that reciprocal. So flip all this over. So this is going to be x plus 2 times x minus 2 over x plus 3 times x squared minus 3 all over x minus 2 times x plus 2. Well, isn't it convenient that I factored, because now these two are going to reduce to a 1, making it much, much easier to work out our problem. Those reduce to a 1, those reduce to a 1, and we're simply left with x squared minus 3 over x plus 3. They seem really similar, but again, this is not the exact same as this, so we can't cancel out this whole term with this whole term because they're not the exact same.